definition of the Doppler effect is an audible, which just means heard, an audible shift in frequency due to motion of objects. So when objects move and they make a sound, you hear a different frequency. Now this is only noticeable for things that go fast, right? Like I'm pacing back and forth, so I'm getting closer to you and further away from you, so I'm moving, but you're not hearing a Doppler effect from me because I'm not walking fast enough. But if you do go at a fast enough speed, like that fire truck, which is not at a significant speed, but is noticeable enough when it's fast enough. So again, if you listen to the sound, you can hear that change in shift. One thing I want to note is the Doppler effect is not volume. So yes, the volume is getting larger as it gets closer and getting lower as it goes away. That's not the Doppler effect. That's just sound is less noticeable the further away you are from it. But the Doppler effect is that frequency change. All right, so what causes the Doppler effect? So the Doppler effect, you could see, is caused by motion. But why does motion actually matter? Well, here's why motion actually matters. All right, here I am creating a sound from an airplane, and that sound is going the same in all directions. And that's because frequency is a constant value that radiates out from the object. So you can see the waves are going the same distance apart the whole way. They have the same frequency, same wavelength. Okay? But what happens as that object moves? So as that object moves, notice that the waves in front, let's make it a little bit more noticeable. Notice that the waves in front are closer together and the waves behind are further apart. That's because when the airplane is making the sound, it makes the sound and then gets closer, and then makes the sound and gets closer, and makes the sound and gets closer. And so every time it makes a sound, the waves are closer together in front and further apart behind. And so I'm going to clap every time a wave reaches my mouse. And you're going to see what happens. So you can see, as it goes towards my mouse, it's happening more often. And as it goes away from my mouse, it happens less often. So there's the sounds being created. And you can see the frequency I clap with changes drastically before and after. So the cause is by sound being the distance between the waves changes. So the cause of the Doppler effect is as an object moves forward, the sound waves appear closer or further apart. So as it moves forward, it appears closer together, and as it moves away, it appears further apart. So as the objects move, the frequency appears different, so it actually is heard different. right? It's not making a different frequency, but because they're getting closer together, it is a different frequency. They're happening more often than you would expect. So let's draw a diagram really quick of this since I already did that. So here's my object. As the object moves forward, the waves are produced closer together because the object is traveling forward. As the object moves away, they're more spread out because the object's moving away from that direction. So you get more frequency in front and less frequency behind. I want to also make a note that it doesn't have to be the source moving. It could be the observer moving too. So if you move towards an object that was creating a frequency, you would also hear it more often. So if I go back to this demo and I put the airplane in the middle so it's not moving, if I move my mouse towards the airplane, I'm going to hit the waves more often than I would if I move my mouse away from the airplane. So if I move my mouse away from the airplane, I hit the waves less often, and so it goes down. If I go towards the airplane, it goes up. So it has to do with motion, whether it's the motion of the object or the motion of the source. So two more examples of this. So race cars. Okay, if you've ever been to a race or watched a race, you know the cars go like that. It's my excellent example. Okay, so when the cars do that, what they're doing is they're coming towards you at a high frequency because the waves are being reaching you more often than they should. And as they go away, they're making a frequency that's less because the waves are reaching you less often than they should. So that's the Doppler effect. It works for race cars. It also works for airplanes. And obviously fire trucks and stuff like that that we talked about. Airplanes are interesting because airplanes can break the sound barrier, which we're going to talk about briefly on Thursday. So we'll talk a little bit about the sound barrier and how the sound barrier works. I'll show you a few things about it. The sound barrier, I think, is very interesting, and we'll do just a quick thing about the sound barrier on it. But airplanes will do the same thing. As the airplane comes towards you, the frequency is higher, and as the airplane goes away, frequency is lower. All right, we're ready for the equation. So I'm going to write the equation first, and it's going to make no sense. Just prepare for it to make no sense. Then I'm going to explain what each of the things mean, and then we'll talk about how to solve it, and I'll show you two examples of how to solve it. Because, like I said, it's complicated to set up, so I want to make sure you can see how to do that. So here's the equation. FO equals Fs times V plus or minus VO over V minus or plus Vs. So there you go. Easy peasy. We got plus and minus plus. We got 3 V's and 2 F's. Perfect. Exactly what you were hoping for on this Tuesday morning-ish. Tuesday noon-ish. Okay, so let's talk about what each of these symbols stands for. So FO is the frequency that is observed. That's why it's called FO. And you can think of that as what's heard or even what's seen. The Doppler effect works with light also. We'll do one kind of bonus problem with light. But in general for this unit, you're going to do it with sounds. Okay, so that's FO, frequency that's observed. FO is the frequency produced by the source. So the thing that makes the sound, its frequency is Fs. So that's the real frequency. That's the frequency the sound actually is. FO is the frequency you hear. All right. V is the speed of the wave.
the speed of the wave. And usually that wave is sound. And if it's sound, it's usually through the air. And if it's through the air, the value is 340. I will give you that number. You don't have to memorize it. But this number you're going to use almost always. Speed of sound through the air. Okay, VO is the velocity of the observer. And Vs is the velocity of the source. Whew! Okay. All right. One last thing to talk about with the equation is what on earth is this minus plus plus minus business? Like, we've never done any equation like this. All of ours are plus or minus. This one is both. And not only that, it's different on the top and different on the bottom, which is just, why would Mr. B do this to you? It's because I'm a horrible person. But it actually makes the problem easier, believe it or not. So here's what they mean. So when you're solving, you have to figure out, do you use the top sign or the bottom sign? You're not always using the top. You're not always using the bottom. Here's what you probably would expect. You would expect going towards the object would use positive numbers, and going away would use negative numbers. But that's not the case. Here's what it is. If you go towards, so whether it's the source going towards the observer or the observer going towards the source, no matter what it is, if you go towards, use the top sign. So in the numerator, that is plus, but in the denominator, that's minus. Okay? And that's because when you go towards, you need a higher frequency. And so that's how you get higher frequencies, by adding VO or by subtracting VS. So if you go away, you would use the bottom sign. Woo! Okay. Got it. Got it. Got it. Probably. So we got all the symbols, got the equation, we got the towards and away business. Okay? So let's solve a problem so I can show you how to do it so that you can use that to do practice 1. So flip to the back page.